Dear students, in this video class, we are going to study the chapter Square and Square Roots, which we studied in the last week also. Today, in this class, we start with finding the square of a number. We're going to find the square of a number. A square of a small numbers like 3, 4, 5, 6 or 7 etc. like these numbers are easy to find. Let me ask you a question. Can we find a square of 23 so quickly? The answer is not so easy, and we may need to multiply 23 times 23. There is a way to find this method having to multiply 23 by 23. That is, we know 23 is equal to 20 plus 3. When we square 23, we can also square this one, 20 plus 3, the whole square. Further, this we can write as 20 plus 3 times 20 plus 3. Now, we can write this as 20 into 20 plus 3 plus 3 into 20 plus 3. When we multiply 20 inside this bracket, we get 20 times 20 plus 20 times 3. 20 times 20 plus 20 times 3 plus again 3 times 20 plus 3 times 3. So when we multiplying these numbers, we get answer. It is easy to multiply these numbers because all these numbers having 0 and the non-zero numbers are, we have here, they are a one digit number. So 2 into 2, 4. Then 2 zeros we can add it, very easy to do it. 2 threes are 6, so we can add 1 0 with that. The same thing here, plus 3 threes are 9. Now only the addition is left. So 60 plus 60, that is 120, plus 400 is 520 plus 9. So answer is 529. Next, example 1. Find the square of the following numbers without actual multiplication. So we have a number 39 and 42. These both numbers are very close to 40. 39 we can write as 40 minus 1. When you square 39, we can also square 40 minus 1, the whole square. So we can write this as 40 minus 1 times 40 minus 1. Further, this can be written as 40 into 40 minus 1 minus of 1 times 40 minus 1. So we can multiply 40 times 40 minus 1 times 40, 40 times 1 times 40, or here minus 1 times 40. So here negative into negative, positive times positive 1 times 1. So we have 40 times 40, this 4 times 4 is 16, 2 zeros we can have here, 40, the same answer here, negative 40 and plus 1. So from 1600 we have to subtract 80 minus 80 plus 1. When you subtract 80 from it, we will get 520. This 1520 plus 1, 5521. So that is the 39 square. Now let us find the value of 42 square. So 42 can be written as 40 plus 2. Then we can square 42. The same way we can square 40 plus 2. Further, this we can write as we did in the previous example, 40 plus 2 times 40 plus 2. Now we can write this as 40 times 40 plus 2 plus 2 times 40 plus 2. Further, when we multiply 40 times 40 plus 40 times 2 plus 40 times 2 plus 2 times 40 plus 2 times 40, then 2 times 2. Multiplying these numbers very easy. 4 times 4 is 16, then 2 zeros, and here plus 40 times 2 is 80, 2 times 40 is also 80, plus 2 times 2 is 4. Now we can add everything, so we'll get 1761. 1700, because 80 plus 80 is 160. When we add the 160 here, 160 with the 1600, we get 1760 plus 4. 1764 is the answer. Next, let us see other patterns in squares. The patterns with the numbers ending with the digit 5. If you notice that all these numbers ending with 5. So what is the square of 25? 25 square is equal to 625, which can be find like 2 into 3, that the 6 can be factorized as 2 into 3. 2 and 3 are the consecutive numbers. തൊട്ടടുത്ത രണ്ട് നമ്പേഴ്സ് ആയിട്ട് നമുക്ക് ഈ 6നെ ഫാക്ടറൈസ് ചെയ്യാൻ കഴിയും. ദാറ്റ് ഇസ് 2 into 3 into hundreds plus 25. 2 into 3 means 6 into hundreds means 6 into 100. 600 plus 25. So 625, we get the answer. The same way, here the 35 square is equal to 1225. This last number always we have 25. The 25 we have it, we are adding. Then if you see that here 12 hundreds is there, 1200. This 1200 we can factorize like 3 into 4. This 3, if you notice that this first number, this digit, the tens place digit is the first number. The second number is the consecutive next number of that number. That is here the 3 is the tens place digits. So 3, the next number of 3 is 4. So 3 into 4, 12. 12 hundreds plus 2 plus 25. 12 hundreds plus 25, that's 1225. The same way here we have 75 square is equal to 5625, or we can get that 5625. So 56, if you notice that 56 we can get from this number is 7. The next number of 7 is 8. So when you multiply 7 into 8, we'll get the 56 5600s plus 25. The same way here 1200, this 125 square, that's 3-digit number. Then you square that, we'll get 15,625. The last, as we see here, the last 2 digits are 25 we get here, and before that we are having 156. Here this if you see that hundreds place and tens place, other than this ones place 5. So if you take this number as 12, the next number of 12 is 13. So 12 into 13, that is 156 hundreds plus 25. So we get here 156 into 100, that is we'll get here as 15,600 plus 25, we'll get 15,625. This can be written like this also. For example, the 75 square, we can write 5 square always will get 25. In all cases 5 square will always get 25. This 7 we can write as 7 into 8. The 7 into 8 is 56. That 56 we can write here. So we'll get the answer as 5625. You can try these numbers, try these questions. Find the square of the following numbers containing 5 in units place. These questions you can try. Here one more question I'll give here as my own. You can give a 85 here. The next we are going to study about the Pythagorean triplets. Consider the following, what I am going to write here. Consider this 3 square plus 4 square. When we look at these squares, 3 square is 9 plus 4 square is 16. So when you add these two, we get 25, which is nothing but the 5 square. Notice that if we add 2 square numbers, we get another square number. So the collection of 3, 4 and 5 is known as Pythagorean triplet. Let us look at another example, that 6 square plus 8 square. 6 square is 36, 8 square is 64. When we add these two, we get 100, which is 100 is 10 square. So when we add 2 square numbers, we end with another square. The sum of 2 square numbers is equal to another square number. Again, let us observe another Pythagorean triplet. When we add 5 square plus 12 square, 5 square is 25 plus 12 square is 144. So when we add these two, we get 169, which is nothing but the 13 square. The numbers 5, 12 and 13, from another such triplet. Can you find more such triplets, children? You can try your own like this. When we generalize this for any natural number, so we are taking a natural number m. So m it is starts from 1, 2, 3, 4, etc. Natural number. It should be greater than 1. It's not 1. It should be greater than 1. So for this one, we have one equation. We have 2m the whole square plus m square minus 1, which is equal to m square plus 1 the whole square. Just like this one, 5 square plus 12 square is equal to 30 square. In the same way, so from this one we can understand that these three numbers like 5, 12 and 13, these three numbers which are 2m and 2m comma 2 m square minus 1 and m square plus 1, we can say it is a Pythagorean, it forms a Pythagorean triplet. So we can say they are Pythagorean triplets. Children, try to find some more Pythagorean triplet using this form. You can substitute the numbers greater than 1 for m, and we can find so many Pythagorean triplets in this format. Let us see this example 2. Write a Pythagorean triplet whose smallest number is 8. So if you see, this number 8 is an even number. Among the three triplets, the three triplets are, one is 2m, another one is m square minus 1, and the third one m square plus 1. This the first one is even number. See, 2 times a multiple of 2. This is a multiple of 2, so even number. So we can take that 2m is equal to 8. From this, 8 divided by 2 is equal to 4. So m value we got as a 4. Then we can let us find the value of m square minus 1. That is nothing but 4 square minus 1, which is equal to 16 minus 1, which is equal to 15. The next third one is m square plus 1. M is 4, so 4 square plus 1, which is 16 plus 1, which is equal to 17. Therefore, the required triplets are triplet is, we can say that it is 4, 15, 17. Here if you notice this number, you should write as 8. 8 is the triplet, not a 4. And also it said that whose smallest number is 8. So 8 is the smallest among these three. Next, let us see example 3. Find a Pythagorean triplet in which one member is 12. Here also in this question, this number is even number, so we can take that. We can first let us write the three Pythagorean triplets, that is 2m, m square minus 1 and
m square plus 1. So 2m we can take it as 12, that we, because it is even number, so m is equal to 12 divided by 2, m is equal to 6. So other two members we should find. So m square minus 1, which is nothing but 6 square minus 1, which is equal to 36 minus 1 is equal to 35. So m square plus 1 is equal to 6 square plus 1 is equal to 36 plus 1 is equal to 37. Therefore, required triplet is 12, 35, 37. It's very easy if we understand. നമ്മൾ ഈ ഒരു ട്രിപ്ലെറ്റ്സിനെ മനസ്സിലാക്കിയാൽ മതി. സോ മൂന്ന് സ്ക്വയർ നമ്പറാണ്. See, if you square this numbers, e number, so all these numbers, when you square that, it becomes as a triplet. Adana question la namukku parayunnathu.